everyone, I'm Mahima Pushkarna, and I am not an engineer. I am a UX designer at Google AI. And I work over here at Google AI. I design platforms, I create tools and frameworks for applied machine learning research. I'm a part of the big picture data visualization group. So the next project that you see, the What If tool, is very heavily reliant on visualizations. I'm also a part of the People Plus AI Research Initiative, or PAIR at Google. PAIR is a multidisciplinary group of researchers, educators, scientists, engineers, and designers who are conducting human-centered research to make sure that human-AI partnerships are more productive, enjoyable, and fair. Our work begins with research. So we're interested in aspects such as model interpretability, model understanding, and even tackling larger problems with machine learning, such as predicting earthquake aftershocks. Our research brings us to platforms and tools, like the What If tool, like the graph visualizer, the embedding projector, and even testing with concept activation vectors, or TCAVs, which is an excellent interpretability method. Based on that research, we follow it all up with a lot of outreach and education. So we're actively publishing in a lot of academic conferences, industry events, and we're also putting out explainables and explorables, such as visualizing algorithmic fairness or describing the geometry of BERT. At PAIR, I lead the design of the What If tool. And we're interested in the code-free and visualization-based probing of machine learning models. So let's talk a little more about that. So today, when we evaluate models, we usually look at global methods, right? We're looking at accuracy, precision, recall, AUCs, and so on. And these give us an excellent sense of how our machine learning models perform holistically. But they don't necessarily tell us too much about the granular and nuanced performances of these machine learning models as we approach individual data points, which is what we're important in as we start to deploy human-centered machine learning models onto products and services. So when we're in a state where we're putting out models which are human-centered, we need to ask questions which support a deeper model understanding. These signify a shift of from testing with just global holistic methods, but actually testing with simulation environments, testing for individuals and testing for groups. That becomes incredibly important to us. And the reason we need to do this is because by testing in a simulation environment, we're able to identify the limitations of our models, and we can actually identify ways to make our models more accurate and more fair. So we wanted to build this tool, essentially, which would let us probe our machine learning models at all these different granularities. And either we could probe these models independently or in comparison to one another, and also in a code-free space, which was honestly going to be very difficult. So we settled with minimal coding. And over the course of almost a year, we built the What If tool. The What If tool is an open source tool for probing machine learning models. It has a graphic user interface, which we designed to help users stress test their models iteratively and intuitively in a simulation environment. We also took a black box approach, so we don't need to rely on model internals to do our analyses. Instead, we work with inputs and outputs to understand where our models perform well and where they perform not so well. The What If tool runs in the browser. This means that we don't need to save any data, and we don't need to send it anywhere either. The fun part about being a designer and a UX researcher working with engineers and scientists and other people on the team is that we designed the What If tool to support multiple workflows. It supports the workflows of both the technical user, the data scientist, the machine learning researcher, the software engineer, but also the non-technical roles that they interact with. So if you're a PM or a business stakeholder, you could very well use the visualizations in this tool to communicate with them. It was also designed keeping in mind novices, which is a huge user group. This includes students who are either in academia or self-learners, but who are looking to learn and grow their skills in machine learning. We also looked at non-machine learning domain experts who are seeking to apply machine learning to their own unique domains. So the What If tool is completely open source. It works in Notebook and in TensorBoard. And in Notebook, it works with Jupyter Hub notebooks. It works with Google Collaboratory notebooks. and most recently with cloud AI platform notebooks. When you're working with the what if tool in notebook mode, it works with any Python accessible model. That means all you need to do is specify a Python function which queries the model on a set of examples and returns results. And then the what if tool, so it'll work with any Python accessible model. And these models could be in PyTorch, in scikit-learn. It could even be in your own custom library, or it could be making remote calls to a server where you're hosting your own custom model. So there's a lot that the what if tool can do, but really the only thing that you need to remember to use the what if tool is pip install wait widget. Right. So what can you really do with the what if tool, right? And how does that work? The what if tool can be pointed to up to 2 models and any data set that you want to actually evaluate the models on. I'm going to talk about some of the capabilities that I'm specifically interested in because I work with a lot of product groups and we use the what if tool with them. The first thing is comparing multiple models. What if tool allows the comparison of up to 2 models across a huge data set, a subset of that data set, as well as individual data points, or even across feature values in your data set. So you can essentially ask questions such as, what nuances in performance must be considered when making trade-offs between multiple models? We're very invested in fairness, but we understand that even achieving a desirable statistical definition of fairness is hard. In a simulation environment, it becomes a little more about unpacking and unboxing what statistical fairness might mean to your model. So using WIT, you can actually test different optimization strategies from a predefined set in a simulated environment within your workflow. You can ask questions such as, what thresholds might help us get to a desirable statistical definition of fairness, such as equal opportunity? Another thing that the what if tool lets you do is asking questions such as, will my model perform equally well for all slices in my evaluation data? This is particularly important in human-centered models because you want your models to work well for a whole group of people, be it young and old, people from different ethnicities. In fact, with machine learning data sets, the question arises, how can you even find these subsets of your data set within your test set? So the what if tool allows you to slice the loaded data set by a primary feature and a secondary feature. So you can evaluate your model's performance for all unique values that exist in a feature such as age. So you can test your model for age is equal to 10 or age is equal to 80 and anything in the middle. So the what if tool you've seen from these screenshots presents a lot of model performance metrics as visualizations, right? We see these as PR curves, we see these as ROC curves, confusion matrices, partial dependence plots, and so on. But the what if tool also builds on the power of Facets Overview and Facets Dive, 2 visualization libraries that we built exclusively for machine learning data sets, so that each member on your team can score through your data sets and identify relevant intersections. So with Facets Dive, you can create custom visualizations using any feature in the data set. And then you can visualize model results as a layer on top of these. So for instance, you could create a confusion matrix in which the individuality of each data point is preserved. You could even color each of these data points by another feature altogether that you're interested in. For instance, if we were to look at the UCI census data set, it could be age, it could be ethnicity, it could be country, and so on and so forth. Over the course of 10 months as we developed this product, we found that maintaining consistency between this big picture what-if analysis was, and sort of very micro-detailed analysis was equally important and very useful. So we tailor-made all our features to allow users to conduct a what-if analysis while deep diving into specific data points and not losing sight of the big picture. So you can ask questions such as, what if I change a very specific feature value? What happens to my model's prediction if I was to mutate some particular value within a larger data point? You could even flip the question using partial dependence plots and ask, how do model outcomes persist along all feasible values of a feature? And finally, something that I'm always super excited about are counterfactuals. When we read Sarah Watcher's work on counterfactuals, we knew we had to find some way of bringing it in. The what if tool does not automatically create a whole new data point, but we did put our own take to it. Given a single data point that you're interested in from the rest of the data set, we find the nearest or the most similar data point that the model classifies differently. And then you can conduct a very simple analysis which essentially puts these two data points right next to each other so you can see what is different and how different it is. Right? So the what if tool it's actually a very simple tool once you get used to it, but it is very complex, and it does a lot of powerful analyses. I'm very excited about it. The code is available at our GitHub page, and we've got a whole lot of demos over here, but I'd love to demo the tool for you in person here today. So let's do that. So today in our demo, what we're going to do is we're going to compare two models that predict if the income for a row in the census data is more or less than 50,000. We're going to test this on 500 data points from the UCI census data set. So I'm just going to see. Right. So when you arrive at the what if tool, this is a web demo. This is what it looks like. The layout is fairly simple. There are 3 tabs on top that can guide you to either a data point editor, a performance and fairness view, or a features view. We try to select the best view given whatever you've put in, whether it's a classification model or a regression model. If you have inference scores available, we try to surface that. We try to find some meaningful default for your analyses. This particular panel that you see is facets dive, which I've been harping on about for quite some time. What it lets you do is it allows you to bin all these data points by any feature in your data set along the x-axis, along the y-axis, or you could do something that scatters it as well. So essentially what you have is you can create histograms, scatter plots, and small multiples in any combination using any feature in your data set, assuming that it's either numerical or it's discrete. So I'm going to go back to inference score 1. So what we're looking at right now, we're looking at two models. One is a linear classifier. The other one is a deep neural network with 1 layer. And we've created a scatter plot of these 500 data points according to their inference scores. What you see here is data points that fall along this diagonal is where models tend to agree with each other. Data points that go further away are places where models might not agree as much. So if you go to the Performance and Fairness tab, this is where we control models and simulate thresholds. Right? You can set the ground truth feature, what your model is trying to predict, or the target feature. And then you can set cost ratios. And then the best part, you can slice and dice your data set. So we're looking at this UCI census data set. This was collected in the 90s. So I'm going to slice this by gender. At this point in time, we have 2 models, model 1, which is blue, and model 2, which is orange. And we've set our thresholds to 0.5. We present the false positive rate, the false negative rate, as well as the accuracy and F1 scores. But you can also expand this to see ROC curves and PR curves. The fun part here is you can actually test and see what happens to your confusion matrix and your positive rate, false positive rate and false negative rate as you pull and play with these thresholds. You can also optimize for different definitions of fairness, as I mentioned earlier. So for instance, equal opportunity, where we're trying to predict the same, approximately the same number of data points as correct predictions in each slice. So if you were to press this, now all of this is happening in the browser, so it might take a couple of seconds depending on how many data points you've loaded in. And equal accuracy. So when we hit equal accuracy, we see how that our model has to be a lot more strict with men than with women, especially with model 2. So if we were to revert everything back to the way it was, so we're working with a very clean slate. We go back to the data point editor. As I said, we've done these fairness optimizations, and now we can actually look at the individual results on each data point. So what you're looking at over here is all the features that are, and its values associated with this particular data point, as well as the model prediction. I can also bin this by age. Say if I'm interested just in 3 buckets. So we've got 17 to 38, 38 to 59, 59 to 80. And then I can bin along my x-axis by, let's say, relationship. And it'll find each category that's applicable. So now what we're looking at is we've sliced and diced our data significantly. But now if I wanted to know how does my model react to all these features, right? We've got partial dependence plots for that. For this particular data point, assuming all else is the same, how does my model perform for all feature values? So for this, we've got age. This is how, so at this point, at the age of 20, our models tend to agree, but you definitely get richer as you get older. That's what this model is saying. But with partial dependence plots for capital gain, we noticed there was something fun happening. You actually get poorer as your capital gains increases before you get richer. And we were actually pretty confused by this. We're like, why is this happening? You know, this is sort of strange. We don't really expect this to happen. So we took a better look at our data. This is Facet's overview. It visualizes aggregate statistics for your data set. And it's also available as a standalone library, so you can compare your test and training data on this. So here what we saw was that there were a whole lot of zeros in capital gains, right? So if we were to like expand this and turn it into a log, we actually saw that a large variety, I mean, all the data points were either early on or they were clustered towards this far end. So what the model started to learn, what our second model started to learn, was that if you declared capital gains between approximately 30K to 90K, you were probably losing a lot more. You were probably not earning more than 50K. So now, say we go back over here, and right now my capital gains is 0 for this data point. I'm going to get rid of these bins so we can find our data point again. It's this one right here. And if I was to edit this data point and say, you know, we've got this much capital gains, you'll notice it's gone down here because it's a null value. The model hasn't yet run inference on it. Then we press this button, it says run inference, and then we actually see what the models are doing now for this data point. It's moved it all the way up here, so the inference score is incredibly high, the confidence score. And the models are fairly convinced that this person, I mean, they're significantly convinced that this particular record earns more than 50K. We can do the same thing with another smaller data point over here. Oops. And once again, we see the shift. It went from being blue to being red. Now, there was one more thing that I spoke about earlier, which was counterfactuals, the last thing that I introduced. What a counterfactual does is really, it queries the model to say, hey, show me a data point from this pool, which is most similar to this data point that I'm interested in, but that the model predicted differently. So how we calculate this is using L1 and L2 distances. And here you can actually select the model. So we're going to work with the linear classifier to begin with. So at this point, this particular data point over here is most similar to our selection, but the model classified it differently. So here you see that they're somewhat similar in age, 44 versus 45. There's a big difference in capital gain. The education in terms of number is relatively similar, but they're slightly different when it comes to real values of education. They approximately put in the same hours per week. Differences include occupation type, but everything else is the same. So when we do L1 and L2, sometimes it changes, sometimes it doesn't, because these distances are calculated dependently on the data set that you have. For our L2 distance, the age difference is a lot more. It's 40 versus 44. And we can also pick this for different models and see how capital gain was different. Once again, education was different, and so on and so forth. This is demo number 2. We're also increasing our support for text models and natural language models in the coming months, and this is an example of that. As I said, we can run this in the what if tool, but this is a text toxicity classifier. It looks at comments on the internet and says, this particular comment is toxic versus this is not toxic, and this is toxic in terms of identity terms, and so on and so forth. This model was put out there by Jigsaw, and this data set is also from there. This is available at the Perspective API, if I'm correct. So here we've defined a custom function over here, and we've loaded in 1,000 data points and given it given a certain height for the tool. So if you were to look at this particular data point, all of these, right, this is classified as a toxic data point, as a toxic comment. And now we actually see that this is what it's borderline toxic if our threshold is set at 0.5, so it's 0.51. But we could actually go around changing this and see how each word affects the model outcome. So if I was to change this word and run inference, we see that now it's not toxic anymore. But then there are still some words that we'd consider toxic over here, right? So if I was to change this last word and turn it into, oh, it's less toxic now. But then this is the part that I found most confusing. I really needed to change this. This was bothering me a lot. So I went in and just said, oh, this should be sound. It will sound like the control police. And I was actually surprised at this particular behavior, where we went from being 0.884 confident that this is not toxic to being 0.854, right? So I asked, I said, why did this happen? I went back to the team. And they told me that what the models had actually learned was that people who use profanity in their comments tend to scramble the letters. So the model has learned that any misspelling is actually adds toxicity to it. So anyway, that was one way of sort of promoting model understanding. And this was just one thing that happened as a result of the What If tool and socializing it with other groups here at Google. So back to the presentation. Right. So we've gone over the text toxicity demo. These are 2 demos. We have many more demos on our website over here. And as it was mentioned earlier, we have a few stations set up outside. We'll be demoing there. We'll be there to answer questions. This is the whole team that's been building this tool. And all our work is available at the What If tool. I'd love for all of you to go check it out, try it out. Tell us if it's useful. You'll also find a link to get in touch with us directly if you have questions, if you have comments, if you have feedback. We really want to know. We're in the process of heavily developing this tool, and we're looking to grow it because, well, it's an amazing tool so far, we found. It's been a great labor of love, and I'd love to open the floor to any questions that you may have.